So I'm going to look at player A first. Remember, step 1 for standard deviation is that you are calculating the mean. So I have to add together each of my individual data points. So that's 10 plus 1 plus 5 minus 3 plus 7 plus 16. So player A would have 36 total yards divided by 6 data points. So that ends up with 6 yards per carry. Player B, if we add their values together to find their mean, it's 5 plus 7 plus 6 plus 5 plus 4 plus 9. I also get 36. Change the color real quick to indicate player B. We divide by 6 data points, and you're going to notice that we also end up with 6. So the challenge here is we've now determined that both players average 6 yards per carry. So it's hard to tell who our better player is. Next up, let's look at their standard deviation. Now, if you think back to the steps of standard deviation, we've already done step 1, which is calculate the mean. Step 2 is going to be to take each individual data point and subtract the mean from it. So I'm going to demonstrate this with player 1 for you. I would take each individual data point, so 10, 1, 5, -3, 7, and 16, and subtract the mean. So -6 from each one, so 10 minus 6 equals 4. 1 minus 6 is -5. 5 minus 6 equals -1. -3 minus 6 equals -9. 7 minus 6 is 1. 16 minus 6 is 10. Next up, I have to square each of those values. So 4 squared gives me 16. -5 squared gives me 25. Remember, when you square a negative number, the result is positive. 1 squared is 1. 9 squared, or -9 squared is 81. 1 squared is 1. And 10 squared gives me 100. So step 2 is now complete. I just finished this one. Subtract the mean from each value and square each difference. Next up, it says sum all of the squared differences. So if I want to go in and add those all together, I would do 16 plus 25 plus 1 plus 81 plus 1 plus 100. I end up with a sum of 224. Move my work over to the middle here because I'm running out of space. So I just finished the sum all of the squared differences. Next up, I'm going to divide the summation by the size of the population. So I've got 6 data points. So I divide this by 6 and end up with about 37.3. So if I look back here, my final step, calculate the square root of the result. So then I do the square root of 37.3. And I should end up with 6.1. So that is my standard deviation for player 1, 6.1 yards. What that means is that on any given carry, you can expect that player to go about 6 yards from the average. So if my average is 6, on most carries, my player would have between 0 and 12 yards. There's exceptions to that, but that's a good predictor. Now, you can repeat the calculation for player B if you'd like to get some extra practice, but what you're going to notice when you start looking at the data is that player A is going to end up with a much higher standard deviation than player B. Player A has carries from anywhere from -3 all the way up to 16. Player B's range is only from 4 to 9. What that means is that player A is not very consistent. If you were the football coach, you'd have to think about what sort of situation your team is in. If you need a running back that's extremely consistent and is going to be very reliable at getting close to 6 yards, you would probably choose player B. If you are in a situation where you needed someone to make a game-winning play and they had to run 30 yards for a touchdown, player A is more likely to have a huge run. Now, player A could also get tackled for a loss, so they're a little bit riskier player. The final thing we're going to think about today is how do we gather our statistics. Sometimes we're able to measure every single thing in a group. Sometimes you're stuck with just measuring part of a group. When you measure part of a group, we call that a sample. When you measure everything in a group, we call that a population. For example, if we wanted to make changes at the freshman center and we interview 3 different classes to see what sort of things we want to change about the cafeteria, that would be what we consider a sample of data, because we're only asking 3 classes out of the entire school. And there's a chance that those classes might not represent the entire school body very well. For example, if we just asked 3 engineering classes, that might not be a great representation of the school, because our engineering classes have a higher number of boys than they do of girls. Or if we measured just 3 weightlifting classes, that might not be a great measure, because we have a higher number of athletes in weightlifting classes, and they might have different meal preferences or eat different volumes of food. If possible, using a population, asking every single kid in the school is going to give you a higher level of accuracy in your data. However, that takes much longer and will be a much more expensive study to run. So when you're collecting data, populations are more accurate, but samples oftentimes are more practical and more affordable. From here, you're going to go and complete the worksheet Applied Statistics.